Hey folks, so I'm working on this new motor. It's a Skilsaw motor that I rewired, and I've got it running on 12 volts DC now. And I've got my bicycle battery here for my electric bike. This thing's getting ridiculously powerful, and you're not really going to be able to see what I'm doing because I've hidden my Waterwheel field behind here, but you'll be able to hear it. I'm going to take this pusher block, and it's just a piece of cabin grade plywood. I'm going to just go directly on the rotor. This is the rotor that came with the motor. It's just an ordinary series winding. It's just a series DC rotor. Well, it's a universal AC DC motor, but I converted this to run on DC. We're running on 12 volts DC. So anyhow, like I said, you won't be able to see anything really, but you'll be able to hear the torque of it. I can barely even bring it to a halt. Now imagine after that power goes through the transmission, a 4-to-1 reduction through that. It's not a transmission, it's just a gearbox, but after it goes through this gearbox, I'm just assuming it's a planetary drive or like a planetary worm drive in there. But it's a 4-to-1 reduction, I know that. So it's going to be 4 times the torque. And it's already, that's enough torque right there that could ride right directly on my back tire and probably push me up the hill. So hopefully this can be a really powerful motor. So anyways, I'm just very excited, and I want y'all to hear it, listen to it again. When I get my finger, if I get my finger in there, it's gonna just cut it, rip the skin or cut it, or if it pulled it in there, it would just rip it off, I'm sure. This thing is bending the plywood. It's got so much torque. The magnetic, you could call it G-force, I guess, but the magnetic force is really, it's not G-force. It's just the magnetic force of the field pole is so strong, it's just literally bending the housing of the motor. That's why it needs to be 3D printed out of carbon fiber reinforcement. But aluminum just sucks for motors. It does eventually bend. It's basically like a molten metal, you know. It just gradually bends and deforms, and pretty soon your motor's locked up. Same thing with steel. It rusts and it locks up. So, you know, quality bearings and then composites, special composites, that would be the ideal motor. And these powerful magnets. There's powerful magnets hidden in here, but this is basically like a magnet motor. See, I'm just holding my brushes on here with my hands. It's not even hot. And you can see this tiny little wire, and it's only 24 volts DC, so it's not taking a lot of current, but it has got some incredible torque, and the speed is fantastic. I mean, this was a Skilsaw circular saw. Alright, I was grinding it to a halt. You know, it's just slightly warm. Slightly warm, slightly warm. Magic. It's a magic trick. But no, it's the special geometry of the magnetic fields, like the Howard Johnson magnet motor. That was actually a patented magnet motor that supposedly just ran on magnet power alone. When you gate it such that the repulsion is, how to explain that? Basically, a magnet motor, you're gating it so that the rotation is coming in. Excuse me. You're gating the magnet motor so that the rotation is coming in at the time where the field is open. So in other words, you can use special materials. You can use the shape of it, you know. You can use other magnets. There's just a lot of ways to shape the field. There's a company that, or used to be a company called what was the name of that company? Programmable Magnets or something like this. Poly Magnets, I think, was the name of this company. They just kind of appeared and then they just disappeared, you know. But they're able to shape the field in special ways. But this is a little bit different, actually. The programmable magnets has shapes that is in the field, but it's still just a two-dimensional plane. So in other words, there's maybe a pattern here, dot, 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 dot. That's a programmable magnet. There's a picture on the magnet. That's not exactly what I'm talking about. I'm talking about the shape of the field in all three dimensions, but also we're just assuming that this fourth dimension is real too. And so we're just trying to avoid those conditions where, in other words, when your flux is perpendicular to your conductor, there's no induction. Okay? So, like the Bruce De Palma and Faraday motors, you know, the field is spinning with the copper. And that's another thing, too. We're going to get into that maybe in the next video. Copper actually repels magnetism. It's not they call it diamagnet, this, that, paramagnetic, whatever. There's so many different terms and terminology. But when it push comes to shove, I found like bismuth is supposed to be the one with the highest number. Okay, well the magnetic field, you know, does go through it. You know, it's maybe not as strong as it could be, but it does penetrate it. But with copper, it literally just induces an opposing magnetic field. You don't even have to think. Yeah, there might be a Hall current there, a Hall voltage across there. And you're going to get a current if you add a load and you create a ground loop, then you get a current. But the Hall voltage is just the Hall voltage. You don't have to always have a counter motive EMF. That's an electromotive force. You don't have to have a motive force if there's no induced current and there's no induced magnetic field in the opposing direction. But if you take copper and you run a magnetic field at it, it's going to induce an opposing magnetic field. That's not... Like I said, just don't even think about the electricity. There are two different things. Electricity and magnetism, they're either at right angles to each other. They literally represent two different dimensions, or they represent two different fundamental particles or fundamental forces or whatever. That part I'm just not even going to argue because I've proven it with my motors time and time again. This motor here, with having that phenomenal torque on the rotor itself before I even get to the gearbox, and not drawing hardly any current. I mean, I'm sitting there holding the brush in my hand. It's not getting hot. The rotor's barely getting warm. No one's really able to explain that very well. Even me, I've got my theories, but it took a lot of hard work and a lot of trial and error too to get to figure out how these magnet motors were gating. And I looked at the Howard Johnson patent a lot too. So that's one I'd recommend people to. You know, if you're going to maybe write your own motor magnet patent, and I say, yeah, build a magnet motor. Why not? Magnet power is real. When you put magnets in there, it gets stronger. I've shown that time and time again. The addition of magnets makes it stronger, and it'll make it use less current. I can't even hold it back with my hand. I'm a pretty strong guy. Thrown the breaker. If you've ever used a Skilsaw before, that would have thrown the breaker. But see, I'm just using little 12-volt batteries there. Anyways, that's the free energy they're suppressing. It's real, y'all. Anyways, just want to say thanks for watching.